Okay, geometry, this is chapter 9, section 5, dilations. If you notice here, we've got a dilation. Our original figure is ADB. The center of our dilation is C. Our image is going to be A prime, D prime, B prime. Notice we are getting larger. Our R value is 2, and R stands for scale factor. So if our R value is going to be bigger, we're going to be multiplying by a number, so we should get bigger numbers. And everything in here is going to be proportional. So the distance from C to A, if I multiply it by my scale factor by 2, I should get the distance from C to A prime. Likewise, if I take my distance from C to B, and I multiply it by 2, my scale factor, I should get the distance from C to B prime. And lastly, if I take C to D prime, or C to D, and multiply it by 2, I should get the distance from C to D prime. So triangle A prime, B prime, D prime is definitely going to be larger than triangle ABD. So if my scale factor is going to be like 1/3, then my pre-image is going to be larger. So here's a rectangle LMNP. And then I've got my image L prime, M prime, N prime, and P prime with my center at C, my center of my dilation. This is also to scale, which means if I multiply the distance from X to M times my scale factor, my R, times 1/3, I'm going to get the distance from X to M prime. So multiplying by 1/3 is going to be the same as dividing by 3, so I'm getting smaller. And you can do that for all of the different segments, to all of the different vertices. And when you do that, you find out that rectangle L prime, M prime, N prime, P prime is going to be smaller than the original pre-image. So my image is smaller than my pre-image. In general, if R is greater than 1, I have an enlargement. If R is less than 1, I have a reduction. And if R is equal to 1, well, multiplying by 1 does nothing, so I have a congruence. So there are all of my rules for scale factor. I have a theorem. This is going to be our first theorem for the year. If a dilation with center C and scale factor of R transforms A onto E and B onto D, so A goes to E and B goes to D right here, okay, then ED, this distance here, is going to be equal to the original distance times the absolute value of my scale factor. So it's just saying that these segments are going to be proportional. So if I go back to my original triangle here, that means if my scale factor is 2, if I take AB and multiply it by 2, I get the distance from A prime to B prime. If I take AD and multiply by 2, I get the distance from A prime to D prime. Likewise, for a reduction, if I take the distance NM and I multiply it by 1/3, I get the distance of N prime, N prime. If I take the distance N to P and multiply by 1/3, I get the distance from N prime to P prime. And that's pretty much what this is saying, is the distance of all my segments is going to change by the scale factor. So you're going to be multiplying by your scale factor.